Hello everyone, GeoGuidance welcomes to you all. Myself Rajesh. Today's topic is film, which is used in camera for photography. Here, basically, two types of films are used. First, black and white films. Second, color films. And when we talk about black and white films, first, its spectral sensitivity is most important. Let me explain what is electromagnetic spectrum. Uh, the electromagnetic spectrum is the ordering of electromagnetic radiation according to the wavelength, or in the other words, frequency or energy. In increasing order of wavelength in sequence, first gamma ray, then X-ray, then ultraviolet, then visible, infrared, microwave, and radio wave. For remote sensing purpose, the most important spectral regions are 0.4 to 14 micrometer, which is lying in optical region, and second 2 millimeter to 0.8 meter, which is lying in microwave region. And we know radio waves are not used in remote sensing. Range of electromagnetic spectrum in which a film is sensitive is called panchromatic, which sensitivity lies in 0.3 to 0.7 micrometer. And sensitivity of panchromatic film is similar to human eyes. And this type of film is also called standard film because it is widely used in aerial photography and for other purpose. This is the typical spectral sensitivity curve for different types of film. At x-axis wavelength is given, and at y-axis log sensitivity is given. Generally, the films show higher sensitivity to red wavelength, and most of the black and white films are quite sensitive to the blue light and need a filter to cut off these wavelengths for optimum result. Further, if an infrared black and white film is to be used for only infrared photography, a filter to cut off the visible radiation is necessary. This is the color negative film, which is consists of several layers. Now I will explain about this. Let us take the pen and draw here first layer, second layer, third layer, fourth layer, and this is the topmost fifth layer. Topmost fifth layer. This is the top layer, layer 1, which is anti-scratch layer on the front. This layer is anti-scratch, and this is second layer, which is called magic layer, also known as emulsion. Magic layer, magic layer. This third layer, yeah, which is anti-halation layer, I will explain. And this fourth layer, which is called actual film. Actual is it actual film? Actual film. Here we can see this diagram, and the lowermost fifth layer, which is anti-static layer on the back side, and actual film, this fourth layer, which is made up of cellulose triacetate. Now magic layer. Magic layer is the mixture of gelatin and light sensitive silver halide crystals with some little granular rocks crystal mixed together in suspension in that gelatin. Here in this magic layer, here some rock crystals are used. In anti-halation layer, which is third layer, anti-halation layer behind the emulsion, this layer absorbs all the light. Once it passes through the emulsion, it makes it so it does not bounce back up. Okay, here when the silver halide crystals are exposed to light, they undergo a change and a latent image is formed on the crystals. Here crystals are present. If you think about what's going on when we take a picture from camera, then we exposed silver halide crystals to light, and when we release the shutter, it means camera shutter, then we have a latent image on the film, and it advances over here into the box and it hides it in the dark, so that we have this latent image next to all these unexposed silver halide crystals. Now, how from latent image to permanent image we get? Here same thing is point which I have explained in previous slide. Um, Now, after this development process takes place. What is development process? I will explain about an example. Let us we take a photo of flower like this. My drawing is very poor. Imagine this is flower, and when we take picture of flower, pictures mean this. This is the camera reel. Camera reel. This camera reel is widely used in earlier time. Let we take a picture of flower. Here, exposing our film to light, that latent image is formed. Latent image is formed on the flower within the silver halide crystal. Silver halide crystals, like small crystals like this. The first thing we need to do is to turn this latent image into a permanent image. Latent image means image we see in this reel. This is called latent image. Now from this latent image we need to permanent image. For this we do this with a chemical called developer. When the film comes in contact with the developer, the silver halide that has been exposed to light turns into actual silver metal, which is opaque. Here by this diagram we can also understood, which I have explained. Here silver halide grains, here this is silver halide grains and ionized silver halide grains, and last metallic silver in this stage. Now we have actual metallic silver crystals and we have the unexposed silver halide crystals that was on the film to begin with. After rising the film in a stock bath, the film is put into another chemical called fixer. In other words, we can say that this film uh, is going to wash, which washes away any remaining silver halide from the film that has not been exposed yet, and in this way we finally get the film, positive film. Now we take its silver metal suspended in the gelatin. Finally we get image. Here the term negative, we use the term negative, it means white color are black and the black colors are white. Uh, when we see the photograph which I get from this negative film, uh, at microscopic level we can see that grains of silver, little, very little grain of silver. When we zoom it, then we can easily see the bright color, which is the grains of silver. In color negative photographs, silver is washed away. Now, color films. Here are three types of primary additive colors: blue, green, and red, and also primary subtractive three colors: yellow, magenta, cyan. All color consist of three layers of emulsion superimposed over each other, and cumulative effect of dye coloring in three layers, different colors shows. Now types of color films. Here two types of color films. One is color negative films and second color reversal films. In color negative film, the three photosensitive emulsion layer, here we can see three emulsion layer are which is sensitive to radiation in the visible range of spectrum. Here we get different types of spectrum. The emulsion layer sensitive to radiation of a particular color is color dyed in its complementary primary subtractive color. This film is useful for remote sensing investigations because it can generate paper positive prints. And in the visible range of a spectrum, one is blue, second green, and third red light. A yellow filter is used to cut off blue light from reaching and sensitizing the green and red sensitive layers. The emulsion layer sensitive to radiation of a particular color is color dyed in complementary primary subtractive color, which gives a negative, that is the object finally appear in their complementary color. And second, color reversal films, uh, which gives directly positive transparencies and widely used in remote sensing and for photography purpose. And also it has two types: color positive film and color infrared film. Now we see uh, what is color positive film. The color positive film sensitivity ranges like similar to the color negative film. Earlier I have explained in color negative photograph silver is washed away, and working principle is different from that film. If the color positive film product is held against the light, normal color of object can be seen. In color infrared film, three emulsion layers are made sensitive to green, red, and near infrared regions of the electromagnetic spectrum respectively. Here in this diagram, three emulsion layer, we can see that this upper layer, which is protective layer, and yellow filter is used to maintain the blue light, and this is a spacer, and this layer is subbing, and this is the basal part. Here the working principle of color infrared films. Uh, at this stage, from exposures to flashing is same as previous, and here one important thing is that it is used in CIR film, which is dye coupler for color photograph. Now by this point we can understood this phenomena. First, exposure. Earlier I have explained. Exposure, it means when we take a photograph and then we get the latent image, and after this developing process takes place, and after this we wash the negative, and again flashing, then dye coupler. Here small and various thin layer are used. After this bleaching process takes place, fixing and then washing, finally we get the CIR film. This film is held against the light, then various false color we get. False color means pseudo color, that is an image that shows an object in colors which is different from that photo. This shows three different wavelengths that human eyes cannot easily identify. This type of film is also known as false color film or pseudo color film. And it is also important because it can discriminate green color from vegetation. So it is called camouflage detection film. Camouflage or cryptic coloration is the same term. Camouflage means color which is same to its surrounding. Generally, army uh, uniform are in camouflage color. Camouflage or cryptic coloration same as surrounding color. The CIR film provides higher image contrast and is particularly helpful when objects have distinct differences in infrared reflectance. Let me stop here, and this for okay. Thank you, and we will see in next video.